These are your ideal volcanoes. When we think about a volcano, I say, okay, draw me a volcano. This is the volcano you guys will typically draw. Okay, they're going to be very steep, very explosive, and basically they're alternating layers based on the magma. Typically, these tend to be, as we talked about very early on, we talked about felsic magma, so very high silica, which means that the magma is very thick, it's very viscous, so it doesn't flow very nice. And then along with that, we have some new ones that we've learned about through this unit, which is the rhyolitic and the andesitic magma. And all three of these basically create a very explosive volcano. And it kind of makes sense. If it's viscous, it's not going to flow through this pipe very easily, right? We go from this very large magma chamber, and it's like trying to force molasses through a funnel. It's just not going to happen. So it's going to get stuck. And when it gets stuck, you build up that gas pressure. And eventually the gases force it through the top, and then that's when it goes. And when it goes, it completely goes. So these are the most violent eruptions that we can think about. This is the one that literally took off the front face of Mount St. Helens. So we think about a normal volcano, we kind of would think of it like this. Literally, this entire front face here went that way. All right, so very violent. Another example of this type of a volcano would have been Krakatoa, which happened in the middle of the 1800s, and that literally sank the island. After it was done erupting, it emptied out the magma chamber so much that by the end of the week, there was no volcano left above the water. So these are very, very.
Is that a picture now, or is that?
That's a picture now. This is the afterwards.
So
we're talking about 30 years after.
What was it before? What did I don't see what it's in yet.
Okay, so you see the divot right here?
Yeah.
Yeah, that wasn't there.
That's all gone.
That's all gone.
Oh, snap. Jeez.
It literally blew out the front face. So, like I said, you think about a geologist hanging out here 20 miles from the volcano. You're not coming out of that.
Yeah.
So those are our three types of volcanoes. So we have composite, also known, I should probably write this down because some of the books do use different terms. This is also called a stratovolcano. Okay, remember, what did we learn about that word strata or strato? Layers. Composite volcanoes are alternating layers. Okay, that's why they call them a stratovolcano. Okay, so composite and stratovolcano are the same type of volcano. Then we have the small cinder cones, right? These are kind of like the firework ones, the little cones that you get during the 4th of July. And then we finally have the huge. These are huge volcanoes. All right, if you really want to think about how big this really is, we think about Hawaii and we're like, okay, yeah, I got it. But what it really is, we think about just above the water. You got to remember that this volcano slopes all the way down to the bottom of the ocean floor. So your shield volcanoes are huge, extremely large volcanoes. Just most of the time, because they form out of basaltic magma, which means they typically are oceanic based, we don't really see the full size of the volcano. And in the case of Hawaii, I mean, you're really looking at maybe that much of the volcano. Well, make sure you go to the big island, 1 and 2.
I don't know. My aunt is in the army, or her husband's in the army, and we're going to visit them in the summer.
All right, so let's go